My name is Alia Batrisyai Binti Aris and my student ID is 2023-886-314.
Hello, my name is Akmarusakinah Binti Azhan. My student ID is 2023-611212.
Hi, my name is Nurul Nadhrah binti Mohamad Pauzi and my student ID is 2023-841448.
So, the introduction. Coffee machines operate using logical systems that automate processes like heating water, measuring coffee, and timing the brew cycle. These systems rely on sensors, control mechanisms, and decision-making algorithms to ensure precision and consistency. For instance, logic gates and control loops help maintain the right temperature, pressure, and brewing time, making the machine efficient and user-friendly. Understanding the application of logic in coffee machine highlights the role of engineering in simplifying everyday tasks.
We established an absolutely new concept based on innovative technology. When the extraction starts, water flows through the induction tube. The coil inside quickly heats it up to the desired temperature. In less than 3 seconds, the water reaches the set temperature and the machine starts to brew your coffee. Your finest espresso is created here, so you are good to go. Embrace the brand new induction technology.
So now we go for the basic connective. Basic connective has two different statements, which is statements and not statements. So statements is a sentence that conveys information or makes an assertion about something. And the key characteristic of statement is that it can be classified as either true or false. For example, Malaysia is one of the Asian country, true, and Malaysia is not one of the Asian country, false. So statements are used in logic, communication, and critical thinking to convey clear and factual ideas. For not a statement, non-statements are sentences that do not assert facts. Therefore, they cannot be classified as true or false. And these include commands like they tell someone to do something but do not make a claim. Second, questions. They seek information but do not assert anything. And the last one is exclamations, like they express feelings or emotions and do not state facts. For example, go outside. There is an exclamation mark after outside. And another one is who get the highest mark in your class.
Logical connective. In discrete mathematics, there are 5 types of logical connective. First one is negation, not. Second one is conjunction, and. The third one is disconjunction, or. The fourth one is implication, conditional if then. The fifth one biconditional if and only if.
Logical statements. There are 5 types of logical statements. The first one is the negation. Statement P, Alin is studying. So if we use this kind of logical connective, we need to put the symbol of logical connective in the front of P statement. So the statement will be Alin is not studying. At this point, we can see that we negate the statement. The purpose of negation is to negate the P statement or any statement. The second one is the conjunction. Statement P, Alin is studying. Statement Q, Ali is taking notes. If we use the conjunction logical connective, we need to combine both statements and put the logical connective symbol in the middle of these two statements. So it will be Alin is studying and Alin is taking notes. At this point, we can see that P and Q, it means P need to be true and Q also need to be true, then the statement will be true. The third one is the disjunction. Statement P, Alin is studying. Statement Q, Alin is taking notes. So if we use disjunction logical connective, we need to put it on the middle or between P and Q statement. So the statement will be Alin is studying or Alin is taking notes. Based on the logical connective P or Q, Statement P can be either true or false. Same for the statement Q. It can be either true or false, and the whole statements will be true. The fourth one is implication. Statement R, Alin studies. Statement S, Alin passes the exam. So if we want to use implication logical connective, we need to put it on the middle or in the between statement R and S. Logical statement will be if Alin is studies, then Alin passes the exam. So in the logical connective, R implies S. Statement R need to be true and statement S need to be false to make the statement false. Otherwise, the statement is true. For the last logical statements is biconditional. Statement R, Alin studies. Statement S, Alin passes the exam. So, if we want to use biconditional logical connective, we need to put it between R and S statements. So, the statement will be if and only if Alin studies, then Alin passes the exam. At this logical connective, statement R and statement S both need to be same. Like if R is true, then S also need to be true. So the statement will be true. If statement R is false and statement S also false, then the logical statement also true. Otherwise, the logical statement false. Like if one of the logical statements is different, like statement R is true but statement S is false, the logical statements automatically be false.
Based on the video, we will get that Akmal want to purchase mocha from the self-serving coffee machine. Primitive proposition. A represent button A is activated. B represent button B is activated. C represent button C is activated. P represent the coffee powder. Q represent the hot water. R represent chocolate. S represent the steamed milk. T represent foam milk. U represent sugar. W represent creamer. If Akmal wants to purchase a mocha, she need to press the button A, so the button will open the partition for coffee powder, hot water, chocolate and steamed milk. After all the ingredients already combined, then Akmal will get the fresh made mocha. The logical statement state that coffee powder P, hot water Q, chocolate R and steamed milk F are included if and only if button A is activated. For the logical connective, P and Q and R and S biconditional A. If P is true, Q is true, R is true, and S is true, therefore the output is true. Other than that, the output is false. If P and Q and R and S is true, A is also true, the output is true. If P and Q and R and S is false, A also false, therefore the output is true. Other than that, the output is false.
This and then you will get the output. The same output as mine. Okay?
Got it. Thank you, Alia, for today. Do you want some coffee?
Sure. I like coffee.
How about cappuccino?
Okay.
Okay, I will get back.
Okay.
When Nat buy a cup of cappuccino from the self-service coffee machine, she needs to press button B. Button B will open the partition of coffee powder, hot water, steamed milk and foam milk. So all of these ingredients will be combined together and Nat will get her fresh aromatic cappuccino. Logical connective. P and Q and S and T biconditional with B. Logical statements. Button B will activate it if and only if coffee powder P and hot water Q and steamed milk S and foam milk T are combined. Truth table for situation 2. From the logical connective, we need to use the formula 2 power of n, which n is the number of variable or the number of input. At the sixth column, P and Q and S and T, the value true and false is determined by combine all the variables using the logical connective n. If P is true, Q is true, S is true, and T is true, then the statement will be true. Then the result will be true. Otherwise the statement will be false. For the last column, P and Q and S and T, biconditional with B, when both P and Q and S and T and B is true, then the output will be true, and the statement also will be true if P and Q and S and T false and B also false, then the output will be true too. Otherwise, if P and Q and S and T false and B is true, the statement is false.
Hello? Siapa dah? You. Kejap. Hello? Okay. Ya. Okay, dah. I think I need some coffee. I feel so tired today, so I need some coffee. Referring to the video earlier, Alia is working overtime to finish her project, and she buys espresso at the self-service coffee machine to stay up for the night. So for each proposition, it represents a specific condition or component in the coffee making process. But for espresso recipe, it only include P, coffee powder, Q, hot water, U, sugar, and the last one is W, which is creamer. So now we determine the logical statement based on primitive propositions. So we got 3 conditions, which is condition 1 is coffee powder P and hot water Q must be combined, and condition 2, either sugar U or creamer W or both must also be included, and the last one is condition 3, which is these ingredients will only work if button C is activated. So the coffee machine's operation depends on the activation of button C, meaning the button C is the controlling factor of the coffee machines. Okay, so for logical connective, we go to the first part, which is P and Q. So coffee powder P and hot water Q must both be present. The logical AND means these 2 components are mandatory. And the second part is U or W. Either sugar U or creamer W or both can be included. The logical OR means one or both must be present. And the last one is biconditional, which is biconditional to C. The entire combination works if and only if button C is activated. The double arrow, which means biconditional symbol, signifies a two-way dependency. So button C activates the process, and the process only occurs when button C is active. For further explanation, to make an espresso, the machine requires coffee powder and hot water as the base, and at least one of the additional sweeteners, sugar or creamer, is necessary. And the process depends entirely on whether button C is activated. So this logical structure ensures the coffee machine functions properly and consistently based on user input. So now we go for the truth table. So we got 4 variables, which is P, Q, U and W. If P true and Q true, the output is true, and other than that, it will become false. If U false and W false, the output is false. Other than that, it will become true. If P and Q is true and U or W is true, then the output is true, but other than that is false.
In conclusion, in the end, modern coffee makers stand as testimony to how logical automation harmoniously integrate everyday convenience and advanced functionality. Sensor, Boolean logic, AI-based algorithm and fuzzy logic are used in these devices for precision, adaptability and safety in their operation. They cater to diverse preference of user while keeping energy efficiency and sustainability in mind, reflecting the evolving needs of consumer. The application of logical system in coffee maker showed the change that automation is able to perform, making them enrich everyday life with involving and practicality.